I'm Anil Kumar sharing with you an excellent question whose answer is not in your book. So I'd like you to understand this video and note down the equation which we are going to develop and apply it whenever required. It is going to help you a lot to get or to ace your paper, right? We're talking about advanced functions, unit 3, grade 12. The question is, what is the relation to find number of turning points from given zeros and their multiplicity? So we need to find a relation between number of turning points and zeros. Now that's the first part. Once you find the relation, then find the number of turning points for a polynomial with zeros at 5. So when we don't write order or multiplicity, it's a linear 0, 3 of order 2, 1 order 4, minus 2 order 4, order 3, using your relation, this particular relation, and then verify the result by graphing the function. So there are two parts to it. Let us see how to do them. So I'd like you to rewind the video and also listen to it once again so that you understand all the concepts. Now let's begin with a simple example where we'll take a polynomial function with just linear zeros, right? So let us say this is our polynomial function. Now here what you see is we have 3 zeros, right? 3 zeros lead to 2 turning points. You see that? So whenever you have zeros, then that means that the graph has to cross them. That means they have to turn, right? Once you cross a 0 and then you have to get to the other 0, you have a turning point. And therefore, we can say that the number of turning points is equal to number of zeros minus 1, right? So let us say you begin from here, cross the 0, you have to turn to get to the next 0, and then once you cross, you have to turn to get to the next 0. This process continues. So we get that the number of turning points is equal to number of zeros minus 1. That is one part to it. Now this particular philosophy doesn't last for long. For example, if I have a turn at the 0, then what happens? Now consider this graph. We turn here. Okay. Now in this case, how many turning points are there? We still have 3 zeros. So we are working with a very simple example, and we are saying that in our example we have zeros, which is equals to number of zeros, let me write, is equals to 3. Now with that, in the first case we got 2 turning points. So the number of zeros was 3 and we get turning points as 2, right? Now we still have 3 zeros. How many turning points? 1, 2, 3. So we still have 3 zeros, but the turning points are 3. Why? That is critical to answer, and that leads to our relation between zeros and turning points. Don't you find it interesting? It is. Well, it will become extremely clear to you if I take another example. Now let's say we have a polynomial like this. So with the 3 zeros given to us, it turns, bounces back, and then turns again. Okay, fine. And then turns again. Oh my God. And there you are. So this time, again, the number of zeros are 3, but turning points are 1, 2, 3, 4, and 1, 5. Oh my God. So what you see here is that with 3 zeros, we could have 2 turning points, 3 turning points, even 5 turning points. Well, there are other possibilities also, you guessed it, and that is like this, correct? If I go like this, but turn here and then go like this, is that okay? Now in this case, I still have number of zeros as 3, turning points 1, 2, 3 and 1, 4. Okay, great job. So we could get 2, 3, 4 and 5 turning points from a set of 3 zeros. Don't you find it amazing? Now, looking into these graphs and possibilities, can you come out with a formula? That is my question to you. Think about it. Take your time. Understand. Now let's get back to the very first one. Here we had all linear zeros. They just crossed. Now if we continue to have linear zeros, we could do one more kind of a graph. Let me see cubic zero. This was turning, right? If my zero was kind of like this, cubic, do you see that? So my graph will be kind of like this. Do you see that? Oh my god, I had to turn here. Sorry, I went so far. Okay, anyway, I think you guessed my point. Okay, let's kind of like this. Then we have less number of turning points, 1 and 2. Do you see that? This one does not have a turning point since it is 0, like odd degree 0. So whenever there's an odd degree 0, it doesn't result to a turning point. But when we have even degree 0, we have additional turn. Do you get the idea? That gives you the formula, right? So let me give you the formula now, and the formula is that the number of turning points is equal to number of zeros minus 1 plus number of even degree zeros, even zeros. Do you get the point? That is the formula. So let me write down bold and clear here. Number of turning points is equal to number of zeros minus 1 plus number of even zeros. That is the relation between turning points and zeros. Whenever we say zeros, we should know what type of zero. What is its order or multiplicity, right? Now let's read the next half. Find the number of turning points for a polynomial with zeros at 5, 3, 1, minus 2. So how many zeros are there? 1, 2, 3, 4 zeros. Let's find out the answer for this. We're trying to find number of turning points, right? So we have how many zeros? 1, 2, 3, 4 zeros, right? So 4 minus 1 plus how many even order zeros? So order 2 is even, order 4 is even. There are 2 zeros with even order, so plus 2. Do you get this? 4 minus 1 is 3, 3 plus 2 is 5. What do we expect? 5 turning points, right? Now, since I've run out of space, I'll use this little space to draw our graph. We have zeros at most of them in positive values, 1 in negative, so I'll draw my line on this side. Okay, does it make sense? Good job. So we have zeros at minus 2. Let's say 1 is minus 2 here. Then we have at 1, 3 and 5. So we have 1, 3 and 5. Okay, let me just make some points. I want to squeeze in. Now at minus 2, the order is 3. That means it will go kind of like this. Do you see that? That is like a cubic function. That is at minus 2. At 1, order is 4. It will bounce back, right? At 3, order is 2. It will again bounce back. At 5 is linear, so it will cross. Do you see that? Let me connect these points. So connecting points is so simple. That is it, right? So it goes like this. Do you see that? It goes like this, it goes like this, and like this. So this is the function which describes. You can count number of turning points. 1, 2, 3, 4, and 1, 5. Do you see the result? Exactly same, correct? So now you know that number of turning points is number of zeros minus 1 plus number of even zeros, right? Remember it, it is going to help you a lot in many different questions. For polynomials, it is kind of essential to know this formula, right? Not in your book, remember that. I'm Anil Kumar, subscribe to my videos and try to max your paper on polynomials. Thank you and all the best.